So today we're going to go through some examples of solving polynomials, and we're going to start by looking at sum and difference of cubes factoring. And I've already gone ahead and put the factoring pattern down there for you. So I like to use the SOFAS acronym to help me remember how to factor these. So once you figure out what numbers are being cubed for A and B, right, you keep the sign the same for whatever it starts with. So if the problem starts with a plus sign, right, the first group starts with a plus sign. If you have a minus sign, you have the difference of perfect cubes, then you're going to start with a minus sign, right? And then SOFAS tells you how to fill in the trinomial part of the factoring. So you're always going to square that first term from the little group that you just wrote down. You're always going to do the opposite sign that you had, right? So I have a plus sign up here, so then I'm going to put a minus sign. Minus then becomes a plus, right? The F stands for first times second, so you take your A and B values and multiply them together. You're always positive after that, and then the last F in SOFAS is to square the second term. So let's do some examples and see how this works. So we're going to factor and then solve these polynomials. Right, so the first example I'm going to do, I'm going to solve the whole thing. So let's see. Let's do 1 plus 8x cubed. Actually, hang on, I'm going to flip it just a second. We're going to do 8x cubed plus 1. Right, so the first thing you want to do is figure out what is being cubed. So I know I have an x cubed, which clues me in that I'm probably looking at sum of perfect cubes. So I'm going to say, okay, I'm going to rewrite this first as something cubed plus something cubed. Right, so it might be helpful to know that 2 cubed is equal to 8. So I'm going to put 2x in here because 2 cubed is 8. And then x cubed is x cubed. And then the one's really easy. 1 cubed is 1 cubed. So my b value in here is going to be 1, and my a value is going to be 2x. So then when I go to factor this, I'm going to set up my little parenthesis set and my big parenthesis set. Right, and I'm going to set it equal to 0 because we are solving. Technically, there should have been an equal 0 in our original problem. I just forgot to write that down. Okay, so my first parenthesis set is going to be a plus b. So it's going to be 2x plus 1. And then we're going to use SOFAS. I'm going to go ahead and write that acronym out. Okay, so the first S stands for square the first term, so 2x all squared. I'm going to go opposite sign, so minus. Front times back, so I'm going to do 2x times 1. We're going to do always positive and then square the back term. So I'm just going to simplify it and write out what that means. So we have 2x plus 1, nothing to do there. So 2 squared is 4, x squared is x squared, 2x times 1 is 2x, and then 1 squared is 1. So now to solve this problem, right, we're going to split it up and set both of them equal to 0. So 2x plus 1 can equal 0, and 4x squared minus 2x plus 1 can also equal 0. So this one's pretty easy, right? We're going to subtract 1 from both sides and get that this is 2x equals negative 1. Divide both sides by 2, and our 1 answer is going to be x can equal 1/2, negative 1/2. So now the thing about SOFAS, the thing about the sum and difference of cubes problem, is that trinomial piece is never factorable. You always have to use the quadratic formula. So, right, our a value is 4 here, b is negative 2, and c is 1. So when I go to solve, right, I'm using the quadratic formula. So x equals negative of b, so negative of negative 2. Whoa, my Apple Pencil is just freaking out today. Plus or minus, right, setting up our discriminant formula, right, plus or minus b squared, so negative 2 squared, minus 4 times a times c, all over 2 times a. Right, and so now it's just a matter of following order of operations correctly. So I like to always find the discriminant first. So negative of negative 2 is positive 2 on the outside. And then negative 2 all squared is 4. And then 4 minus 4 times 4 times 1 is 16. All over 8. So x is going to equal 2 plus or minus the square root of negative 12 all over 8. So then I'm going to break down the square root of 12. I'm just going to go off to the side and do that. Right, so first I'm going to pull off that negative 1, and that's going to give me an I. And then I'm going to break the 12 down because 12 is just 4 times 3, and 4 is a perfect square, so this is going to become 2i times the square root of 3. So I'm going to get x equals 2 plus or minus. I'm going to put my 2i square root of 3 in here. And now if I'm looking at this problem, 2, 2, and 8 are all divisible by 2, so I'm going to divide the top and the bottom of my fraction by 2 to reduce it. So my final answer here is going to be 1 plus or minus I square root of 3 all over 4. And there we go. So I'm going to do one more example for you guys of solving. Right, and this time let's do a -1, and we'll make it a little bit more intense. Let's make this, this is a good problem. Okay, we'll do 250 x cubed minus 54 equals 0. We're going to solve this problem. Okay, so whenever you see a problem that only has 2 terms and you have to factor it, you always want to ask yourself if it's one of your special factoring patterns. So if it's a squared term, right, that's usually difference of squares. And here I can see I have an x cubed, so I'm probably trying to do a difference of perfect cubes problem, right, a Sophus factoring problem, but 250 and 54 are not perfect cubes. So before we do anything else, let's take out a GCF, right? You always want to take out a GCF no matter what kind of factoring problem you're doing because it makes the numbers smaller. Right, so 250 and 54 are both even. They're both divisible by 2. So I'm going to take a 2 to the outside. And that's going to leave me with 125 x cubed minus 27. Okay, so 125 and 27, both perfect cubes, so we're in good hands here. So the 2 on the outside, I'm just going to leave that so we can totally factor the left. And then inside my parentheses, I'm going to work on breaking down these numbers and defining my a's and b's. So 125 is 5 cubed, so I'm going to make this 5x in here. So 5 and x all cubed will give me back 125x cubed. And then 27 is equal to 3 cubed, so I'm going to plug 3 in for my b value here. So my GCF is just going to hang out on the outside. So we don't have to do anything with it, but just don't want to lose it quite yet. Right, and then I'm going to set up our Sophus factoring pattern. I'm going to actually move this down a line so we have a little room to write that. Right, so we're going to leave the same sign in the middle in the first group, and we're going to put our a and b value in, so 5x and 3. Right, and then we're going to follow Sophus, so square the first term. Put in the opposite sign. We're going to do front times back in the middle. We're always positive. And then we're going to square the back term, square the last term, so 3 squared. And then it's just a matter of simplifying it. So I guess I'll leave my GCF of a 2 red on the outside. Right, so then I'm going to get 5x minus 3. Times 5 squared is 25, x squared is x squared, 5x times 3 is 15x, and plus 9 there, or 3 squared. So then, right, we're solving, so we're going to set all of our factors equal to 0. So I'm going to set, technically what we do is we set the 2 equal to 0, right, but that's ridiculous, there's no solution there. So then I'm going to set 5x minus 3 equal to 0 and 25x squared plus 15x plus 9 equal to 0. Okay, right, so if I solve 5x minus 3 equals 0, I'm going to add 3 to both sides. I'm going to get 5x equals 3 and then divide by 5. So I'm going to get x is equal to 3/5. Reversed it in my head. Okay, so we have one of our answers, and we know this is a cubic problem, so we should be finding 3 answers. So the other 2 are going to come out of our quadratic. So A in my quadratic is 25, B is 15, and C is equal to 9. So I'm going to go ahead and just set up my quadratic formula. Actually, I'm going to go ahead and find my discriminant value before we even do that. Just make this a little easier. Right, so the discriminant, remember, is b squared minus 4ac, which is going to be 25 squared minus, oops, that's not right, 15 squared minus 4 times 25 times 9. And right, we could figure that out in our head if we were given enough time, but I'm going to cheat and use my calculator. And by cheat, I mean I'm just going to use the easiest option. Not really cheating. So I'm going to get that this is negative 675. So right, we're going to go ahead and set up our quadratic formula now. So I'm going to get x equals negative of b. Right, just setting up my little pattern here. So negative of b, so negative of 15, plus or minus the square root of the discriminant, all over 2 times a. My a value is 25. So now if you have done a couple of these solving SOFAs problems before, solving sums and differences of cubes, the cool thing is if you look back at your original a value, so the original a value is 5, and 5 cubed is 125, that number always comes up when you're breaking down the discriminant. So right, if I go off to the side here, right, this is equal to negative 1 times the square root of 675. So that's going to give me I times the square root of 675. And then 675 is equal to 1, where am I going with this? So 675 is equal to 225 times 3. So sorry, I was misspeaking earlier. So, right, you're solving a perfect cube problem. So the cool thing about sums and differences of cubes is that the square root of 3 is always going to show up in your answer. So when you're going to break down the square root of that discriminant value, if you just divide it by 3, you're always going to figure out the other part, and the other part's always going to be a perfect square. So, right, kind of running out of room. So 225 is equal to 15. Square root of 25, rather, is equal to 15. So we're going to get I times 15 times the square root of 3. So when I go down here in my next line, negative of 15 on the outside, so negative 15 plus or minus, I'm going to get 15i square root of 3. And then 2 times 25 in my denominator is going to equal 50. So then if I look at all 3 parts, right, 15, 15, and 50 are all divisible by 5. So let's divide the numerator and denominator by 5 to reduce our fraction. So our final 2 answers to this problem are going to be negative 3 plus or minus 3i root 3 all over 10.